The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello everyone, I'm geologist Philip Ong. I'm here with Mr. Dane DuPont. We're with Hawaii Tracker, hawaiitracker.com. We're bringing you guys another Kīlauea volcano eruption update today on January 25th, 2021. It is the 36th day of this ongoing summit eruption of Kīlauea volcano on the big island of Hawaii Island. And we're gonna, first thing I'm sharing with you guys here is the time lapse from the USGS Hawaiian Volcano Observatory's KW cams, just kind of showing the weather over the past day has been one of the big issues with a lot of the signals we've seen. So we'll talk about the weather, but we're gonna also take some questions at some point during the chat. So Dane is gonna be checking out the chat, answering you guys' questions online if you can. I'm collecting questions to pass along to me for live segments, and checking our stream and all that. So shout out to Dane for handling all of that while I do the narration today. So today, Monday, after the 5 full weeks of eruption here on Kīlauea, we've had a real downpour of rain today across much of the east and south part of the island, some of the middle as well, and in fact the mountains are under winter weather advisories right now, Mauna Loa and Mauna Kea. So for those who are not aware, it does snow in Hawaii. It's snowing on both our mountains right now. But we are focused today on Kīlauea volcano in particular. And so here you can see that view looking from the west towards the east into that pit of Halema'uma'u in the summit of Kīlauea volcano. North would be off in this direction over here. We're looking kind of from the west. And we're seeing where the west vent down here at the bottom is putting out this incandescent lava that's kind of whitish in the nighttime camera, and you can see a little bit of red in the one dawn picture. And then in the daytime, a whole bunch of steam. And so it's really a fascinating view to see that steam moving and dancing as it kind of all billows up and out of there. And it shows you all the other areas which are actually hot, right? So maybe I'll back this up to our original USGS page here and show you guys the still image here, so you guys can kind of appreciate what areas are actually hot, like all the way up the crater walls, not just the lava itself, right? So the heat is going into all the rocks surrounding us, and so you can see that that's where all the steam is coming from. All right, so kind of a survey of the Summit webcams. This is what I had loaded up a few hours ago, so you can kind of see our S1 cam. Also can't really see the west vent, so back over here, the big island and the lava lake is in here. The lava lake's all down there. You really can't see it in this view. And that's the KW camera we're just looking at. We look in the KE cam, you see a whole bunch of fog, a bunch of rain. There's probably not a lot of photographers up there now, although the ones that want time to themselves will be, will probably be very, very empty today. So kind of scrolling down, here's our thermal camera, and our thermal camera looks a little different. You can't really see the back edge very well of the crater because there's a lot of steam obscuring the view. So that's one of the signals, for example, that's being obscured by this rainfall event that's happening here. All right, so I'll move on from this particular graph and I'll show you guys the thermal time lapse. And so you can kind of see some flickering and some kind of psychedelic colors there as it's hitting that wall of steam and hot steam, right? And picking up the temperatures, and it's obscuring the view through to the backside to some degree. You can kind of still see the active vent down here at the bottom all the way through. You lose a lot of detail further back when that thing's flashing off and on, right? So the extreme weather on the island is a challenge at times. And so that's just kind of one example there. And so I don't give anyone any seizures. I'll move on and show you guys this National Weather Service series of images showing rainfall accumulation total for 3-hour periods. So this is starting last night. You can kind of see that our winds come from the east, and that rain pattern is moving kind of east to west across the island, and the reddish is kind of the most intense rain in this particular image. Red is up here at the right end of our graph. So we're going to look at, instead of looking at just the rainfall, we're going to, something that we've looked at before is the USGS stream gauge heights. And so you can look on Hawaii Tracker, hawaiitracker.com, and see Dane's post earlier today about the different gauge heights. And so here's an example of the Wailuka River in Hilo cresting to about 14 feet gauge height, whereas it was around 2, a little bit over 2 before that. So this is not a record event by any stretch of the imagination. We had something like this a couple months ago. Our record was actually Hurricane Lane. So if you want to know more about that, go on Hawaii Tracker and check out Dane's write-up on that. And so you can kind of see the east side of the islands. We have this similar kind of spike, Honolulu showing a spike as well. And on the north side, you really don't see a whole lot of accumulation here in the last couple of days, right? You do see a couple of rainfall events earlier in a week, right? And similar in the north, and here in South Hawaii and Pahala, we do see that event coming up. So you can kind of see South and East Hawaii is where we're being hit with this. All right, West Hawaii also not happening. All right, so I'll show you guys this camera. This is the time-lapse camera from the USGS Hawaiian Volcano Observatory of Makua Ve'oveo, which is the summit caldera of Mauna Loa volcano. So you can kind of see as the image begins here yesterday, right before sunset, you see some blue sky and you see the clouds kind of coming in. And by the time dawn rises, so there's snow covering the whole landscape. And so I just want to put this out as like, there's a whole bunch of other cameras on Mauna Kea. Perhaps on Hawaii Tracker, you can find some of those. If not yet, then shortly someone will probably post those. So, but on Mauna Loa, for example, one thing I want to point out, and I'll just start with that, is we can look at the tilt signal. The tilt is measuring the change in the sagging or swelling of the ground, and that can happen from the weight of water, or in this case, possibly snow. So sometimes you do see an excursion, right? Something like this, where it looks like the signal is taking a real change from its original trend, and that's just happening at the same time as this rainfall event. So that is a suspect signal right there. It's hard to say, volcanic signals can happen at the same time. They can possibly even be induced by water if they're right on a tipping breaking point, like we've discussed before, although that's unusual. Usually the magma pressure is so huge that it's just trucking through all those other obstacles, right? And then, the last little amount to overcome that the rain would overcome is usually just like one little blip for the magma. So usually the magma takes care of all of it, and rather than the rain. The rain can have an effect. And so that's something we want to keep an eye on. And we do this long enough, and you come across these events. They do happen every few months, every so often. So on Kīlauea, it's harder to tell what's exactly going on, because here's our summit Uekuhuna station, and we have a natural we had this deflation-inflation cycle happen a couple weeks ago, and we had a deflation-inflation cycle last week, and we've actually had another deflation-inflation cycle. Appears to be inflating here at the right side of it. And I can zoom this in for you guys. And we'll look at Kīlauea Summit in a little more detail at the USGS site here shortly. So these are USGS plots, but I've kind of just put them all in one place so you can see them all together. So Sand Hill is the southwest side of the crater. We're a little bit more in a rain shadow. You don't see such a big rain event. You do see a couple of deflation-inflation events, and it looks like you do see like an inflation signal coming in here at the end. If we look a little further east to Kīlauea Iki is looking a little suspect. You see, if I can show you guys that this green line over here, right? This green line, it's all the way over here, and then comes up a little bit, and then boom, it shoots way up. So you can see that this is not normal what's happening here at the right end. So if I zoom into it, you can kind of see there what that actually looks like. It's a very unusual kind of suspect signal. You kind of see that. So we're gonna look at a couple of these today, just because we want to know what we're actually really looking at. Summer camp station is not coming in. On the East Rift at Escape Road, we see something similar as well. Right here at the end, we see deviation from a much larger deviation than anything. If you look at the scale of this one, it's interesting, right? This is a scale on this particular graph of that's 1 microradian, 2, 3. It's come up almost 2 microradians, and that's as large as the entire change it had in the whole last month before that due to the volcanic events. So sometimes these signals locally can be very, very influential, and that's why it's so important to kind of be careful of them. Looking at POC station, Puu Oo. Now this is looking pretty suspect as well. What's going on right here? It's a giant spike here in the end. So for all you volcano watchers, when you see this kind of thing, it's important to also know what the weather is like nearby, and not just presume that there's magma moving, right? The Puu Oo station is not coming in. We look over at Jonica, we don't see that big signal in Jonica, so it can also be very localized, where some stations get it and some don't. And it's kind of interesting to watch how it actually happens, and track that over time, right? And kind of try to correlate that with where the rainfall patterns actually are, if we have that much detail. A lot of this area is all thick rainforest. There's no rain gauges out in the middle of there, so it's kind of just some estimate, but you can imagine there could be some local effects as well. All right, so let's go to the USGS. Where's my USGS site? All right, lose it. It's over here. Oh no. So yeah, first we'll talk about why this is the case. And so here's a map showing mean rainfall for the month of January and island of Hawaii. This is from the University of Hawaii in Manoa, from the 2011 Rainfall Atlas of Hawaii. And so in this case, they're showing blues. The darker the blue is where the more rain happens. And so you can see our big bullseye pattern of blue is over here. Oh, kind of drew the arrow the wrong way, but there it is. Kind of one locus north of Hilo. Hilo town is in this bay. This is Hilo Bay right in here. And another focus is kind of closer to Kīlauea. Kīlauea caldera, if I zoom in, you can kind of see its outline right there. That's Kīlauea caldera. So you can kind of see it's right near the edge of this blue thing, and you can kind of see it very quickly in a short distance of space. Right, coming over here, you cross quite a lot of change in rainfall. And so depending on which station that sand, the outlet station in the southwest is over here, right, you kind of see it's a lot drier than the station at Kīlauea Iki, which is over here. Right, so you can kind of see that we've actually crossed two whole contours, right, just in that short amount of space in there. And that's why also knowing where these stations are is an important aspect of the integration of the monitoring signals, right? So when we serve all these monitoring signals, we're trying to incorporate all this data. And of course, I'm broadcasting you guys from near volcano, from Kīlauea Summit, and Dane is down in Leilani Estates, right down the road from Ahu'aila'au, also known as Fissure 8. So we can kind of give you guys that on the ground, correlation. That's something that's easier for us to do since we're around and can actually watch the weather than someone who's watching from the mainland, for example. All right, so moving on, you can kind of see that the Kona side has oh, it's not going to work with that. All right, the Kona side over here has all those drier signals, and so we really have a rain shadow where we have a wet side of the island and we have a dry side of the island. All right, and then the south side gets it a little more in the winter as well, and that's where that Pahala south side signal came from the tide gauge we showed you guys. All right, so that's kind of the why of it, and so when we see these signals, it's important to look into that. So here is the USGS deformation site, and let me make sure I get the most recent update. And so now we have the past 2 days, and we're showing it appears to be we're certainly doing all this big deflation. And then down here is a kind of interesting little wiggle. It wiggles down and up. And so there's some kind of rain effect somewhere in here, and there's some kind of interaction that's unknown. But it appears like that it is inflating. Okay? And so this station is in the northwest, so it's a little bit more in a rain shadow. It usually gets a little bit less rain than some of the other stations, but depending on the storm, they can get quite a lot of rain as well. I remember at one point being at Wikahuna and looking into the crater and seeing waterfalls cascading into a Kīlauea Mau crater that was empty of any lava, but something like 8 or 9 waterfalls pouring in off the edges, so it really can pour a lot of rain up there as well. Zooming out to the last week here, Kīlauea, you can kind of see this is a more typical deflation, and kind of bottom out and then sharply come up, and you kind of have that kind of cavity, like the curve is kind of facing up. That's typically how it goes, and it did it again here, so another deflation cycle. And we don't have quite as clean a pattern over here, but it does appear like it's doing that same kind of inflation cycle over there. So zooming out to the last month, you can see we had that longer inflation cycle that maybe was something like this. And we also had these couple little wiggles right in here, which are interesting. And then we had the one last week and a second one kind of back to back. And this is not uncommon. The interesting thing, I suppose, is we don't really have a chance to see what the base level is, but it appears like it's not that, like, what I'm curious is whether this thing is going like this, or whether it's going like this, or whether it's going like this. Right, those are important tools for the prognosis of what might happen next and how long eruption might go on. So that's the blue line we're looking at here in Kīlauea Summit. The green line is Puu Oo, which we're ignoring for now. All right, so if you look at the pattern of these, and this is kind of interesting, the one we're having now, the one that happened last week, might be only 4 days apart, something like that, 3 to 4 days apart. So if you go 4 days back from there, it's somewhere in the region of these 2-3 little wiggles over here, which happens to be 4 days back to this end. This is kind of an extended event over here, but there's almost this is almost trying to be some kind of adjustment as well, right? So you almost have a pattern of 1, 2, 3, 4 of these, kind of obviously more frequent than anything we saw before that. We saw some small variations, and we saw on the 26th the switch over from the north vent to the west vent, and that's kind of what it looks like going back off the left of the chart like that. Before we had our first deflation-inflation event, the first week of the year here. So that's our tilt, that's our pressure variations, and so you can see pressure variations are still continuing. You guys saw how the lava lake stopped overturning, or stopped flowing and actually began overturning the last time that this happened. It's interesting to note that we're not seeing that same pattern this time. And so that's kind of interesting to see how that can be different from time to time. And interesting that we documented it last time. But there are other cycles happening in the volcano. In fact, if we look at the photo and video chronology from the USGS HVO once again, they have this couple of pictures. One from 4:18 p.m. on January 22nd, I believe, and one at 4:21, 3 minutes later that same day. And so you can see within 3 minutes, you have a big flow coming out of the vent and kind of a much weaker flow coming out of the vent. And so at this point, I'll switch over. There's actually a video of this going on. And so let's look at this. And I'll kind of just recap to you guys the caption here. Cyclic fluctuations and eruptic vigor were present recently at the Western Fissure. The cycles occurred on January 22nd and 23rd, with cycles lasting 5 to 6 minutes. Peaks were expressed as high flow rates in the channel and spattering at the vents. During troughs in the cycles, the channel became nearly inactive. These variations may be due to oscillations in the height of the lava column in the vent. The video is shown at 90 times speed. All right, so let's play it here for you guys. And it's coming, I believe. There it is. So 90 times speed. You can kind of see it pulsing, right? You can look at here. You can look at the spattering up here and up here as well. And kind of at the base of this, you can kind of see the swirl of lava coming out as these pulses come through. So every 5 to 6 minutes, it's a much shorter cycle than the deflation-inflation cycles that are on a 4-day maybe back, back and forth cycle, something like that.
Interesting thing about that is the 5 to 6 minutes. Wasn't that the pulse duration during the 2018 eruption?
There were some similar pulses out of Kīlauea down the road from Dane in 2018. Yeah, exactly. So I'll put that one back. If you want to talk about that a little more, Dane, your experience of it.
Yeah, just the two types of variations that we had at the end of the eruption. In June of the eruption, it was very steady fissure rate. Like you couldn't see any variation on it. But when you got into July, especially mid-July, you would have these periods lengthening between the collapses at the summit. And then after one of those collapses, you would get about an hour and a half later, a surge at fissure rate, right? Where lava would come out in a greater amount. But during the periods in between, like when we were 12 hours after the summit collapse, but like 18 hours before the next one, you would get these pulses that would every few minutes, you would get an oscillation in the vigor of the eruption. And those were pretty regular, especially near the end of the eruption. They're much more pronounced. When the pressure was really high, you just couldn't see them at all, it felt like. But yeah, those are, so when you're saying 5 to 6 minute oscillations, it's like, well, that sounds a lot like what we were seeing then, at the end of that one.
Right. So that's something you expect to happen as eruption kind of goes on and kind of starts, puffing out, at least the end of that one batch of magma. Not to say that there's not another batch coming, although it seems like what we just have is built up pressure over time based on our conversation last update. So yeah, it's interesting to kind of, to look at that and compare it, and really we can only speculate, right? What's really causing that, right? So we'll have to wait and see, and then we'll look back with 2020 hindsight, and we'll be able to explain it a little better. But one thing we've described before is how that might be a process of what we call gas pistoning, right? Where gas is building up under some denser magma, and then it's coming up, and it's kind of being released, and then the magma is able to, the denser gas poor magma is able to go back down and move down that pathway out of the way. But somewhere the pathway is narrow enough, they had to take turns. One's got to go down before the other one can come up. So going down, deflation, coming back up, inflation, right? Something like that. And that's kind of a hard thing to kind of imagine. So I thought I would, today just pull out this old video from 2006 of gas pistoning inside of Puu Oo and play it for you guys. So you guys can kind of see this process. We have this pad of lava coming up, and the gas is pushing it, and it kind of just pops the bubble, and then the lava drops back down immediately, and you can't see it rising at all. This is once again a time lapse, really sped up. USGS HVO footage once again, 2006. I'm sorry, from June. So daytime and nighttime views here, but that's what it looks like if you actually could see it. So if something like this is happening underground, then it can be expressed at the surface by more lava comes out, less lava comes out. It's more gassy, it's more spattery, it's less spattery, it's more low fountaining. That's the kind of thing that the process that we're talking about when we're describing gas pistoning is exactly this. So throw that in here one time, and we may come back to this in the future once again. But there is one more USGS video released today, and that is from 3 days ago on the 22nd. And this is another thing that's similar to 2018, and this is flames that were observed numerous times at the western vent in Halemaumau at Kīlauea Summit. The combusting gases are not certain. They're not sure what exactly is igniting there. But the flames were observed numerous times in Halemaumau during the early 1900s lava lake. So I'll play this for you guys here and see if you guys can see some of these flames. And there's no organic material in there. So here's our main western vent, right? But what you're looking for is over here on the side, these little pukas, these little holes. There's one over here on the right side as well, over there, that kind of are shooting out flames. Right? You can see that the gas is coming out, the lava is actually coming out here, but there's some other volcanic gas, possibly sulfur-rich, right? Some kind of sulfur gas that's actually igniting and shooting out as flames here once in a while. So that is a fascinating thing here, right? Because we don't have any there's no organic material to burn to form a bunch of methane, for example. So we can't say it is methane. It doesn't look like it's actually like burning. The color looks kind of an orangish from this particular exposure of the video. Hard to really tell from there. But so another interesting effect there happening at the summit. Right. And yeah, so kind of I mean that pistoning video I showed you guys. I mean that was Puu Oo, and that was area that's no longer active. It's kind of just historical, just so you guys understand what kind of process is happening underground over there, right? And Puu Oo crater was it was a large crater, but it was quite a bit smaller than the Halemaumau crater is now, and so it's that. I have to go back and look at the diameter of that pit, but something like maybe 10 meters or something like that. 10 meters, 30 feet. I would estimate as the size of that pit that we saw the lava coming up and popping up at the beginning. So, all right, back to our photochronology. This is our most recent image. This was taken. Doesn't say the date on here. Maybe if I scroll over, yeah, the 22nd. So 3 days ago, and you can kind of see that at this point in time, reduced flow out of the west vent. Maybe I can zoom in a little more for you guys to see. Tag to disappear. All right, there's the west vent. So a little less flow. You still see lava coming out and flowing out both this way and this way. And we have the island. The edge of the island is over here, looks like, on the bottom right. So if I zoom out, there is the island, and lava's going all the way around both sides of this thing. That way, and around this way as well. Right? So it's actually liquid all the way around the island still. And kind of over here to the right, you can kind of see we're forming a new rim. It's like a new rim over here. That's kind of the edge of the more liquid lava. Right. And so one interesting thing to notice is we'll look at this little detail here shortly. But as the reports of the lava lake continue to rise, right? So our number today, I want to say, is 205 meters, somewhere 670 something feet. So it's still coming up, and the height of the island above the lava level is not changing, right? So that implies, it hasn't been stated outright, but that implies that this island is still rising with the lava lake. Right, that's one little detail to kind of pay attention to there. And there may be, we'll give you guys more of a detailed synopsis on all the movement of the edges and all that, and this crust in our more in detail analysis on Wednesday. But there are also well, I'll leave that. I'll leave that thought for now, and pardon me, and I'll just keep going so I don't go off in too much of a tangent here. So we'll zoom in here. This is the backside of the island. This is the island over here on the left side, and so that flow coming around. Right, it looks like it's a big lava flow, and it may be flowing on top of the crust a little bit, and then once it actually breaks that thin crust, then you can go through that overturning process, the foundering that we described to you guys in the videos last time. And then see what else. They got those two videos down here, and that's the update today for their photos. So under text here, get my color different. So our important number is 205 meters, 673 feet deep. That's the number today. It hasn't really changed in the last 3 days. It's hard to tell if that's because it's hard to measure that through a bunch of rain and steam, or because we've been deflating through the depressurization, that cycle. So it could be that when that happens, the lava lake actually pauses its filling. In some cases, actually seems like it drains a little bit. We'll look in more detail shortly. And otherwise, the last measurement of gas was still January 16th, also because of the weather, 2,500 tons per day. So this would be an interesting number to know, but we can't know it when we have the weather like this with our current techniques. So otherwise, nothing new much of anywhere else. They are noting several days here that they're correlating positively the tilt at Wikahuna and RSIM is seismic amplitude measurement, right? So it's basically the amount of tremor, right? So the amount of, if we look at our seismometer, our seismographs, how much wiggle, how much ink are we putting on a paper, is a way to think of what the RSAM is. And that corresponds with high tilt and high RSIM with greater lava effusion. Right? So that's the pattern we pointed out to you guys a couple of weeks ago now. That was seen also at the summit Hale-Ma'u lava lake. All right, and here is where it talks about the island being at the same elevation above the lava surface. Right, this number here actually may have changed. So, but that's something to track right there. It's like whether the island's rising or falling, or the lava density can be changing as well, and that's something interesting to us. So, looking at the lava levels here, this is the current eruption page of the USGS, and we showed you guys this plot last time, how we had before in green the hand measured values of the lava lake depth, and then over here on the 8th they installed the novel laser rangefinder, and from that point on they had an automatic measurement in blue, and that was going great until this rainstorm came in. And you guys can kind of see, if I zoom in more here, that it's showing that the lava lake in a couple of days went all the way over 350 meters from 200, so we didn't gain 150 meters. We can tell from the webcams that's not true. Nothing else happening. This is a limitation of the rangefinder with the current weather we have. And there's different kinds of rain. Obviously, and it's not just raining a little bit. It's been pouring rain here. Like where I'm broadcasting from, we had something like 8 inches in the last 24 hours. Which is for Hawaii not that unusual, but kind of gives you guys in the mainland some perspective of how much it can rain out here and how that can influence these signals. So we're not sure what's happening exactly right there. And it's a lot harder to see what I wanted to show you guys before, which is that if it looked like before the signal was on here, we could actually see on our lava level like it was going down during that deflation-inflation cycle, and then coming back up afterwards as well. So if that's the case, then how do you drop the lava level in the lake? There's a couple ways you could do that. One is just kind of cooling and contracting from losing gas, right? But the other way is there could be one of those fissures down at the bottom of that lake somewhere. It could be draining some of the lava out. And so the fact that the lava level is dropping, you'd like to know how much it's dropping and be able to calculate that with the gas being lost as well. But maybe you could get at some measure of, well, maybe there's some drain back happening somewhere under that lava lake, because we know that originally we had a whole bunch of different cracks that lava was coming out, and all but that one set is buried now. So they're all candidates for areas where the lava can flow back down, even if it's much slower than it's coming in. So just a small little detail there. All right, and then this page also has, if we scroll down, the gas measurements, but no new gas measurements because of the weather. So if we look at the VOG model, you can kind of see that there is still some emissions and reds on the map for VOG levels. And because the Kona side isn't getting quite as much rain, it's not having its air cleared out of VOG like the east side is. So over here it's going to be all green because there's just no room for VOG in the air with all the water kind of just, washing it out. But you do see the yellows kind of over here, this area. And as the winds were coming from the southeast earlier, we actually saw earlier there was some wind, some of the fog was coming across the saddle and making it into the North Kona area that way. And I'm not sure if that was, yeah, you can see it right there. At some points it's coming across around Mauna Loa in the saddle here between Mauna Loa and Mauna Kea. The saddle being this kind of high junction between them right in here. All right, so that is a gas. It's still happening. Earthquakes are still happening. It looks like we just had one pop up here, a 1.9, right at Mauna Loa Summit caldera, but just one by itself, no cause for alarm. We have our whole Pahala cluster down here, so I'm now showing the last week of earthquakes, which means that only the orange ones are in the last day, and then the red ones are in the last hour. So the ones in the last day are over here, one over here, a couple over here, and then this is the one that was in the last hour right in here. So nothing unusual there with the earthquakes. For more info on Pahala earthquakes, if you missed our stream highlights, go back and check out our channel for our interview with Brian Shiro, USGS geophysicist. So nothing really to speak of here. And with that, we can move on to some questions, Dane, and we can see what our viewers want to hear about for the rest of our broadcast today.
All right. Well, thanks for the breakdown. So before we get into the questions, we just got to say that, we are brought to you by HawaiiTracker.com. Hawaii Tracker is a community-based resource for sharing information. We're trying to create basically a social media network, but it's more community-focused, and we are able to do this type of production via viewers like helping us out. Number one way you can help us out is just share this video, right? Make sure to like, subscribe, that type of thing. The second way is to go on HawaiiTracker.com, make an account, join up with us, and become part of that community. And third way is through monetary support. We have a donation page on HawaiiTracker.com/support, and through that enables us to keep these type of productions and keep the research going to be able to provide this kind of content. So with that, we do have a few new donators we'd like to thank. Germand S., Miriam M., Susan E., Denise J., Elizabeth W., Perry V., Jessica N., and Robert G. Those donations really help keep us going. Especially there's a few that did monthly donations. Those really, help keep us going when times are quiet, right? A lot of the support comes in when the eruption starts and then tinkers out over time. But it's important to be able to do this, the research continually, to be able to, keep the understanding and the communication going. So with that, let's jump into some questions. We got a few here, mostly about the rainfall, but we're talking about the tilt meters and the lines kind of going crazy on those. What do we have a question here about what do the blue and green lines represent on the tilt meters?
Okay, so that depends on which plot you're looking at, but let me get the tilt meters up here for you guys and talk through it a little bit here. All right, so the normal USGS webpage right here, Kīlauea deformation data. This is the one that, like this plot's easy, is only one blue line. That's Wikahuna raw. This one, when it shows a past week, it's got a blue one and a green one. In this case, this label over here is what's telling us what's what. So we'll zoom in to that. And if we look closely, it gives us a 3-letter code that actually stands for, this is a station name. UWE is Uekahuna, and Puu Oo is Puu Oo. Right, so this is telling us that the green line is Puu Oo and the blue one is Uekahuna in this particular case. So there are a few plots on the USGS site that these kind of index ones on this page especially, like this month one down here is the same thing. The green line is Puu Oo, and the blue line is Kīlauea Summit at Uekahuna. Right? There are a few that actually compare the summit and rift zone, because that's something that we saw that's our status quo, is lava going through Halema'uma'u and coming out of Puu Oo and erupting at Puu Oo. And we would often see these deflation-inflation signals mirrored at Puu Oo shortly afterwards. Right? I have some old ones to pull up. Maybe I can maybe I can find one here to show you guys what that looked like. Just give me a few seconds, and I bet I can get you guys one. Yeah. I'm not finding one that's showing. Oh, maybe that one. I have these all over the place, but there's not easy to find right now. Maybe November. Sometimes I'm looking for an old tilt plot from before 2018 that shows that relation between when a deflation happens at Uikahuna and then when it happens at Puu Oo. So I'm just going to pull up this Anderson figure instead.
Right.
I'm just going to pull this Anderson figure instead and kind of show you guys, for example, here. Look at this bottom plot right here. This one over here is Uikahuna, and a kind of more reddish, and a blackish is Puu Oo. Right, and kind of see that the signals look very similar. Right, and if you were to zoom in, you see there's actually maybe a 2-hour to 4-hour delay. Sometimes a little bit longer. There's a range of delays, but that's more or less normal. Normal, quote unquote, was a few hours delay between a single signal at Puu Oo afterwards, after it happened at Halemau'u. So that's why they show these two together, right there. Right. I'm going to skip GPS today, but there are other times when I've showed you guys some of these other plots, like this Jonica station, right? And so, in this particular case, if we look at the raw, and the way you get to this one is you have to go to the main USGS page, which is, where did I put it? Okay, so if you go to the main USGS page, and monitoring map, Kīlauea monitoring, for example, and you have all these different symbols for all different kinds of stations. This little red one with like kind of a dumbbell shape thing here, that's the tilt meter. So if I click on one of those, for example, Puu Oo, then you can click on it, and it'll give you one of these plots like this, right? So in this case, these kind of plots, when you look closely at the scale, it shows green as Puu Oo and blue as Puu Oo also. But then there's a number here at the right side. And this is an azimuth and 0 to 360, 0 and 360 being north. So 45 is about northeast, right? And that's going to be about northwest, 312, right? So this is the tilt in the northeast direction, a tilt in the northwest direction, 90 degrees to each other, right? And that's how you can tell where the source of inflation is coming from. Is it coming from your west? Is it coming from your east? Is it coming from your south, from your north? That helps you figure that out. And so that's the key, is looking at the key.
All right. The way I always did it was, the way I always envisioned it is, if you took like a square board and place like a ball under the middle of it, and then you tilt it one direction, you have two lines that act, will go up or down, or depending on which way you go. And that's kind of always been the way, just conceptually, I look at them. So yeah, we have another question about the lake itself, the lava lake. Do you think the crust of it could remelt on the eastern half? The crust at top.
If you had enough hot lava come in, then it seems like you possibly could. But the longer that doesn't happen, the less likely it is to happen, because it's cooling off more and more and more and more, and it's a mass balance at some point, right? At some point, it becomes no different than the rocks on the side of the crater, and they could melt a little bit too. But at some point, it's more like how much heat are you bringing in compared to how much heat are you taking out through radiating into the sides and radiating into the atmosphere and blowing it away, and that's what it's really all about.
Right.
So yeah, it could happen, but it seems unlikely to me at this point. But what could happen, we've seen a little bit of indication that crust has cracks in it, because there was a spot during inflation that there was a little lava popped up in the middle of the crust and made a short little flow. So it could pop up from the middle of the crust and then flow over itself and repave itself that way. That's something that could happen.
Right.
And then that might induce the thing to sink or to form other different kinds of islands, or who knows at that point. Kind of depends, like how buoyant the stuff is, how many of the small islands are in a particular chunk of that crust. Right, so that's an interesting thing to, if we ever cross that bridge.
So Janet asks about measuring instruments at the caldera. Do they have any inside the caldera? Like what types of monitoring do they have in the caldera floor?
So there are some, right? And the nanosensors, I'm not sure anymore what they all are, right? We do know, we've seen pictures from the USGS of them installing new seismometers on that downdrop block right above the lava lake. And so we know for sure there's one there. There used to be a station called North Pit that is now where the pit is, that fell in, right? So we know that there's a South Caldera GPS station. There are definitely seismometers down there. So there's quite a few stations, on the caldera floor, kind of all around. I mean, not like a dozen or anything like that, but kind of one at each edge, more or less. Right. And if you guys go to the national park and visit the steam vents, you can kind of look down over the rail. Or you can look down, if you look at the right angle, you can see these kind of white boxes with a radial antenna and a solar panel, and that's some kind of instrument, whether it's a seismometer. There are usually down there, I think, seismometers. I don't think there's any tilt meter down on the floor. So there can be seismometers or GPS usually. And there are also portable gas stations that sometimes you see as well, but I don't think that any of that data makes it to the website. But they do have it accessible. You do see those in the park as well.
Yep. All right. So we have 2 questions about Puu Oo, and I sent you a picture to pull up for this one. First question is about the how wide is the Puu Oo vent, and the second one is there any activity at Puu Oo?
So no activity at Puu Oo really. I'll show you guys a plot in a second. Here's a picture of the dimensions, and so the width across here, 320 meters of the whole crater, 1,000 feet or so. And at that point in time, this is an old picture. The lava was going to that June 27th flow and going towards Pahoa. That's a long time ago now. It's
right.
A couple of lifetimes ago now. As far as pool activity, and maybe now I will go back to I wasn't going to go too much into this plot, but if we look at the GPS for Kīlauea, we can see that at the summit, you had a big drop off when eruption happened right here. And then kind of came back up, we switched vents, then went back down, and came back up, went back down. It's almost following that deflation-inflation pattern, which is interesting as well. That's how slow it's happening. It might even be coming up on a GPS, right? But we're going to look at Puu Oo, and to answer your question about Puu Oo, the trend at Puu Oo is still one of contraction. This is a label showing the length between North Puu Oo crater and Jacuzzi is a South Puu Oo station. And so this is the distance across rift zone at Puu Oo. And when magma comes into it, like magma was filling that area, we can say that this post right here is most likely that, right? It was filling it beginning in June at Puu Oo. And when eruption happened, it started backflowing towards the summit. And unlike other parts of the volcano, which maybe have stabilized, this is still contracting. It may possibly still be emptying. It's either emptying or it's empty and still just sagging from it not having anything else in it. One way or the other, it is sagging, but there could be actually flow out of there going back to the summit, if anything. So at the surface, no activity. I think the last gas measurement was almost 3 weeks ago now, but no detectable gas coming out of the crater either. And all the signals are that everything is going back towards the summit.
There we go. So, activity. We have Darlene asking a question on Facebook. I'm going to rephrase it a little bit, but 2018 there was many different vents, and the activity had a lot of variation between what vent would be active, especially during the first month. Do we expect to see any vent changing and vent swapping between active vents any longer with this eruption? And is there any way of knowing what the pattern is?
It's as I've mentioned a few times, these are all just kind of surface fingers from that major blade. And so, yeah, the actual, I like to think of it as almost like a nozzle. The nozzle can change, right? But the actual source is what's really directing everything. And so kind of the fundamental answer is really like it all depends how long it lasts. If it lasts a long time, then you're guaranteed to have some vent changes, because at some point you'll have more pressure coming through, and it might be too much for that one vent. It might open a crack right next to it and come out the side also, and then now you have a new pathway. Or if it stays deflated too long, you could actually almost freeze closed one of those pathways and then force, when it reinflates, for it to come out of another crack. So the longer it lasts, and the more of these pressure cycles it goes through, the more likely it is to go through some kind of vent change. Right now, there's no reason for it to change the vent at all, unless it were to deflate for long enough that pathway actually constricts. Right? Maybe we're seeing something like that, but it is also possible that we're seeing just a decrease in the gasiness of the lava that's trying to come out right now. So that's kind of hard to balance exactly why it's coming out a little bit less, right? But I don't expect this because it's clogged, because we're not seeing that inflation that steep inflation like you'd expect it when it got clogged. When we saw the north vent got clogged, it was a pretty V-shaped. Suddenly it started inflating again because it couldn't get out as much as it wanted to. So, yeah, it's a great question, Darlene, and yeah, thanks for that. And we'll have to wait and see, really.
Jared asked about the ebb and flow between Mauna Loa and Kīlauea, and that now that we're seeing a waning of activity at Kīlauea, do you expect any activity at Mauna Loa?
Well, thanks for the question, Jared. I think it's a little too soon to say that activity is waning at Kīlauea.
Right.
It could be that this particular eruption, even if eruption stops right now, I wouldn't say that it's waning, because it's the one erupted more recently, right? The last how many eruptions? In the last 50 years of eruptions have all been mostly Kīlauea, right? So with one Mauna Loa little blip. So 70 years almost, right? So two Mauna Loa blips, if you go back that far. But Mauna Loa does seem to have some interesting patterns of when it erupts, kind of compared to Kīlauea caldera collapses, right? But that's something that's really, really short in historical record as well. We only have limited information about that association, and it's really hard to kind of predict that. So if you go back to our updates kind of, back in early 2019, we're talking about that as well. We're thinking well, here's the long-term patterns. We presented those papers, and we thought maybe now that Kīlauea is essentially recovering, Mauna Loa will take her turn. And Mauna Loa has been inflating slowly but surely, but she's been doing that for many, many, many years already. And in the end, it was Kīlauea that erupted first. And so maybe the long-term supply rate is greater to Kīlauea right now still. And Kīlauea is going to just keep going, and Mauna Loa might erupt if she's given a chance because of the changing dynamics of Kīlauea, right? But Kīlauea don't necessarily won't turn off, I don't think. You know what I mean? That's kind of my particular take on it there.
All right, we're starting to run down on questions. I do got one more here. Is there any chance of further collapse at the summit of Kīlauea? And if it did, what are the range of possibilities, or a few of them?
Yeah, I think there's always a chance of collapse. It's kind of always on the table. That's something the volcano does, right? It puts out lava, its summit collapses, it puts out lava on its roof zones. Like, that's the things the volcano does. So it's going to happen at some point again, but it seems more likely like it's going to refill the hole first before it collapses, because it's got a way out, and this, that way out is right there at the top. The collapses seem to be associated to some degree with rift zone eruptions, like big rift zone eruptions. So if the lava is able to make it through the rift zone and out the rift zone at some low enough elevation, which was, for example, in 2018 in Leilani, but it's also happened in the 1800s in the southwest rift zone as well, right? Big eruptions out of the southwest rift zone that cause caldera collapses. So right. Either side could be what's actually doing it. And so until we see magma moving to the rift zones, we don't really have to worry about that. But it's going to happen at some point again. That's just kind of the cycle of, we know Kīlauea had, I don't know how many incarnations of calderas that are around, but there's various iterations of them.
The interesting part to me is always when you look at even like 1960, 1955, the summit, and the deflation that happened that was associated with the eruption in the Loris Rift. It seems like there's some line some threshold that exists between the deflation that's expected with rift zone and eruption activity, and it going into collapse mode. Right, where we start getting into, I don't know where you would classify the collapse, where that line is drawn, what starts, where does it transition from large deflation event to a summit collapse. I wonder if it would be that cycle it seemed to get into with the collapse events, right, with those big 6.4 equivalent drops of the caldera floor.
Like 5.2s, 5.4s.
Or 5.2, yeah, 5.4s, that was it. Yeah, sorry. If that would be the consideration on that, I'm not sure. What's your thoughts?
Yeah, I mean, the papers that USGS has put out since, they recount that it took less than 4% of the upper magma chamber draining for the collapse to begin. So there might be some threshold like that. And in the end, it might have been, as much as 33% or as little as 11% that actually left that upper reservoir. Maybe if you get to that 4% range, maybe it's a volume thing. You get to 4%, then you start to collapses and kind of go from there. But it's all about the volume, right? And you can gain volume either by leaking it out the side, but then we also have that whole enigmatic south flank that actually is what's the boundary of the rift zone. And so if it moves away, suddenly the rift zone's got more space and lava can go in the rift zone and possibly not even erupt and still cause a caldera collapse event or summit collapse event, if not the full caldera. So 1924 is an example of that, where there was 6-foot offset on the faults in Kapoho, right? And the magma moved all the way through there. The south flank moved away, and we think the magma went actually all the way off the island, offshore. And maybe it erupted underwater, maybe it didn't. There was no report of anything that, there's nothing conclusive, really. Let's put it that way, right? But that might have not even erupted on the island at all. And that was a huge event as far as how much the ground shifted and the caldera, at least the summit Halemaumau crater being formed. And that eventually leading to those explosions later on, right?
So, we do have one more question here about lava risk in Fern Forest from the East Rift Zone in the Fern Forest area. Maybe you could talk upon that briefly.
Yeah, so let me see. I need to bring some kind of map up here or something. And I don't have like the hazard map, but maybe I'll use the earthquake map if I can figure out where I put it here.
We can just use one of the lava zone maps, maybe, huh?
Yeah, I'm not sure where I put one of those though, so I'm gonna.
I'll drop it to you.
Okay. So let me kind of just give you guys a little orientation here. All right. Let's transition here and show you guys this hazard map. So, all right. We have hazard zones 1 through 7, or 1 through 9. 1 is the most hazard, and 9 is the least hazard. It's just lava hazard. There's all kinds of other hazards that include flood, for example, when this is just lava, right? And we look at the volcano, and zone 1, the highest risk, is this reddish rib that goes southwest, the southwest rift zone, the summit caldera itself, and the southeast rift zone over here. And that's zone 1. That's, as I like to describe it, the ground will crack open there and lava's going to come out of the ground in zone 1. That's where it's going to happen, is in zone 1. Almost all the time. That's where lava comes out of the ground. Zone 2 is downhill of zone 1. So anywhere downhill of zone 1 is where the lava is going to go. After it comes out of zone 1, it's going to go into zone 2. So it's the lava may not come out of the ground right there, but lava is going to run from right out of the ground nearby towards you if you're in one of these areas at some point. hopefully when you're not around. Right, and so this is kind of the thing. Geologic time. This is a certainty geologic time, but it's not a certainty in any human time, right? So that's kind of why people play these games of like, well, I can make it. I'll take the risk. It's not going to happen to me, and that kind of thing, right? But that's where the real risk is, right? So the fern forest area is right here in this zone 3. So fern forest is kind of an area runs like this, more or less. I'm probably drawing too big. And so for lava to get there, it'd have to come from an uphill area. And the way that the contours run, they kind of run something like this, right? So it's hard for lava to get from here to there. It has to come more from here to there. Maybe I should draw it in red so you guys can see it. So the lava's got to come more from this direction to get to fern forest, right? And that's the direction of Kīlauea Iki is on this side of the caldera. From Puu Oo, the lava might try to go here, but then it kind of ends up curving down this way every time, right? That's kind of the path. On the north side, it always kind of wants to go like that. On the south side, it goes straight down. Right? So, but for it to get from forest, lava is going to come out from the top over here, right? So, if lava erupts anywhere inside the caldera, there's a giant cliff on this side that the lava can't get past. Right? And if it fills the caldera and it pours out eventually, it's going to come out this way, not the southwest rift. Right? And it's kind of a little, call it a blind spot, if you will, right here in the middle, where the lava kind of usually goes around the sides, and so less frequently will it actually wiggle into there, but it rarely will do that. So Zone 3 is, in the grand scheme of things, for an insurance company, a normal risk, right? You can get a regular insurance policy in Zone 3 with your regular national insurance company. That's like where they draw the line of like, acceptable. Whereas it's harder, it's still possible to get insurance for Zones 1 and 2. And oftentimes that comes with an extra premium because of that extra risk for lava flow. The same thing might be true if you live in a floodplain. You might have an extra risk of, flood you got to pay for, or tornado or hurricane or whatever it may be, tsunami if you're right by the water, and living right at sea level. In this case, this is the lava situation here. So that's Kīlauea. And so on Kīlauea, fern forest is actually one of the lowest zones you can get, right? Acceptable risk. It's the same as Hilo. If you look kind of farther up, all of Hilo is also in Zone 3, right? That doesn't mean out of harm's way. Remember, Mauna Loa put out a flow in 1984 that came down like this and got almost to Hilo, going this way. So Hilo was threatened before. It will be threatened again, but not that frequently in Zone 3. Other areas that are a lot less likely. Mauna Kea is a 7 and 8. Kohala is a 9. Then you see Mauna Loa has got a couple little blind spots also. They're labeled as 6s here and here. Right? And then Hualalai, it's like special.
It's the Hualalai wildcard rating.
It's the special pupil here. It gets its own category. And we can discuss that some other time. So,
all right, well, that does it for me on the question end.
All right, well, thank you guys for joining our broadcast today. That is our update today, January 25th. We'll come back to you guys on Wednesday and give you guys a little bit more in-depth analysis, maybe some more historical context on some topic or another. If you guys want to put in your requests, let me know. There's all kinds of things that I'm working on that are on the table, including some of the groundwater stuff, some Loihi hotspot stuff. There's anyways, you guys just let me know like what you think might be the most interesting thing most relevant thing. It might be water at this point. So we'll see.
Might be. I'll keep an eye on the comments for you.
Yeah, right on. So thank you guys. Thanks again, Hawaii Tracker, hawaiitracker.com. You can go and find all of our content over there, and as well as our updates in between our live videos that we try to put out on most days. So on behalf of Dane DuPont, I am Philip Ong. Aloha.